Good morning. Yesterday, we discussed parallel plate capacitor and its capacity without dielectric medium between the plates and with dielectric medium between the plates. Right? Next, we continue. See, without dielectric means what is present between the plates? Air or vacuum. If air or vacuum present between the plates, what is capacity? Epsilon naught A by D. With dielectric. Completely filled between plates. The space between the plates is completely filled with dielectric. Whose dielectric constant is K. This gap is completely filled. Then C, K epsilon naught A by D. Right? This is what we discussed yesterday. K epsilon naught A by D. Can I write this as epsilon naught A by D by K. D by K. Epsilon naught A by D dash. Right? From this, what is this D dash? D dash is equal to D by K. Epsilon naught A by D dash, where D dash is some distance in A. Epsilon naught A by D dash is the formula for capacity. When a gap is filled with A, it appears like that. Epsilon naught A by D dash. But actually, we derived it from this formula, K epsilon naught A by D. Whenever a dielectric medium is kept, is completely filled between the plates. This distance D dash equal to D by K is called air equivalent. Air equivalent distance. Air equivalent distance. Right? What is air equivalent distance? See, I'll give you one example. These are the plates filled with air, separation D in A, let us say some 2 meter or 2 units. A is the area of the plate. If I ask the capacity, epsilon naught A by D, epsilon naught A by 2. Well, same plates, separation increase, I increase the separation. I filled this gap see here, this separation is D in medium, D with medium, which is some 10 meter, where K is some phi. Now, see, epsilon naught A by, we have a formula K epsilon naught A by D in medium. Can I write like this? Epsilon naught A by D in medium by 2. D in medium is 10, K is equal to 5. What it gives you? C is equal to epsilon naught A by 10 by 5. Epsilon naught A by 2. See? Epsilon naught A by 2. Epsilon naught A by 2. How much separation here with the medium? 10 meter, let us say 10 units. With a dielectric K, 5. What is its A equivalent separation? 2. With A's separation is 2. With dielectric medium, with separation 10 and K5 is similar. For both capacities same. Right? So can I take this D by K, D medium by K, D medium by K. Is air equivalent. The distance between the plates when distance between plates D medium with some medium is D medium with some medium of dielectric constant K gives same capacity as distance between plates with A plates, I take it as B with A then A equivalent A equivalent of that particular distance is D of medium by K. Right? In this example, with the A separation D, it is giving some capacity. But here separation increased, the gap is filled with certain medium. See, distance is not same as this. This is 10 with the dielectric medium of constant phi. But in these two cases, we are getting the same capacity. Whatever the factor we get here, distance thing, that is equivalent to air distance 2. Yes or no? We got 2 here, we got 2 here. When we got 2 here, whenever D in the medium by K, here D in the A. So D in A can be written as D medium by K, which is equivalent of A separation. A equivalent, we call it as. Okay, right now. Next. So without dielectric between the plates, with completely filled dielectric between the plates, we studied. Okay. Next. When gap between the plates partially filled with dielectric medium constant K. When a space between gap between the plates is partially filled with the dielectric medium of constant K. What does it mean? See here, this is one plate, this is another plate, a capacitor. Separation is D. Separation is D. Okay. Now, this is a dielectric slab. This is a dielectric slab. Which is kept between the plates. But see here, it is not completely filled. Its thickness for this dielectric slab, thickness is T, and its dielectric constant is K. Now it is partially filled, not completely. Some part is covered with air, some part is covered with dielectric medium. In this case, what is the capacity? Come on, think. What is the capacity? See, distance covered by air. Can I write D minus T? D minus T, where T is thickness of dielectric, distance covered by air is total D minus this T. Here is A, here is A, this is dielectric slab, right? D minus T. Distance covered by dielectric medium T. But we have one facility. If distance covered by dielectric medium, we can convert it into air equivalent. So air equivalent. Can I write T by K? Just now we discussed if a dielectric medium covers T distance, its air equivalent is T by K, right? Now this is the distance covered by air. This is air equivalent by the medium. If I add these two, that gives total distance covered by air only, right? Total distance covered with air medium D. I call this as D of air medium. Distance covered by air plus D dash, that is air equivalent of medium. Air equivalent in the sense that gives the distances when covers with air, which gives the same capacity, just previously we discussed. Okay, so what this is, distance covered by air is what? D minus T, and air equivalent is what? T by K, right? Then can I write like this? D minus T. See, from these two I am taking T common, minus T common, 1 minus 1 by K, right? D minus T into 1 minus 1 by K. If I write like this, D minus T plus T by K, from this minus T common, here 1, here 1 by K, minus 1 by K, minus into minus gives plus, yeah, 1 minus 1 by K. Then what is the capacity now? C, capacity of this capacitor when a gap is filled partially with this dielectric, Ct, I call it as. How much it is? Epsilon naught A by D of A, you can simply call it as epsilon naught A by, what is this? D minus T into 1 minus 1 by K, right? This is the capacity. You understand this? Whenever it is filled like this, first take air distance D minus T and take its air equivalent T by T, and that is equal to the total space is covered with air D minus T into 1 minus 1 by K. Clear? Right now. See here also what happens to capacity? Epsilon naught A by D minus of something. Minus of something means denominator is decreasing. When denominator decreases, capacity increases. Right? Whenever the gap is filled either fully or partially with a dielectric, what happens to the capacity? Capacity increases. Increase. Clear? Come on, note down. Well, based on this, they ask one question. Whenever the gap is filled partially with a dielectric slab of thickness T and dielectric constant K, capacity increased. CT, capacity is C. To bring back the capacity to the same value, what to do? Think. It's an application. That is like this. See, initially, plate separation is D. A is the dielectric. A is the dielectric. Here capacity is C now. In this gap, a dielectric slab is introduced like this. A dielectric slab is introduced whose thickness is T and whose dielectric constant is T. Then what happens? Capacity changes. Let us say that capacity is Ct. Which is greater? Whenever dielectric slab is introduced, we know capacity increases. Once, see here two things happen. One, slab partially filled. Partially fills the gap. One, capacity increases. The base Ct is greater than C. Second question, what happens to potential difference between the plates? Let the potential of the plate, positive plate. Potential difference B. See, we have a formula. Q is equal to Cd. Right? Here, charge on this plate is Q minus Q. Here plus Q. Here minus Q. Charge is not changing. In both the cases, charge is not changing because there is no connection to the battery to take the charge. Once charged with something, that charge remains there on the plates. When this is introduced, charge remains same, but what happened? Capacity is increased. Capacity increased, it remains same, constant, but this is increased. What happens to this? It decreases. Remember this. Whenever a dielectric slab is introduced between the capacitor plates, capacity increases, potential or potential difference decreases, right? Potential or potential difference V decreases, right? The question they ask on this is to bring back the capacity to the same value C naught, to bring back the potential to the same value. Here if I take potential is Vt, here potential is V naught. Vt is less than V naught. The question they asked like this: to bring back the capacity to initial value C naught, initial value C naught, or potential to initial value V naught, how much separation to be increased? This is the question. How much separation to be increased? Right? Why separation has to increase? If you take C naught, epsilon naught A by D. If you take CD, epsilon naught A by D minus T. Is it not the formula? Epsilon naught A by D minus T into 1 minus 1 by K. Here, D minus T. This is minus. So something is subtracting, decreasing, denominator. So C increasing. So if I increase the separation, between the plates, this denominator increases. Once denominator increases, CD decreases. So we go on increase that separation till the CD again becomes C naught. CD again becomes C naught. Okay, how much to be the increase in separation to get the original values C naught V naught again? For that, what to do? Separation has to be increased by how much? This is the question asked. Okay, you understand that question? Let us see the answer. Come on, note on this. See, I am rubbing this. Here what we are doing, initially there is a separation D, then we are increasing the separation. See here, up to here D, then I increased the separation. Actually the plate position is this, here, from here to here, D, then I increased the separation. I took this plate little bit above. This increase in separation, I am calling it as X. Separation is increased by X. Slab is as this. Slab is present here with a dielectric constant K and thickness T. Now what is the total separation? D plus X, right? In this case, capacity, new capacity, I call it as C dash. Come on, tell me. Epsilon naught A by D plus X. D d plus x. Here A distance is d. See here, total distance is d. So we write it as d minus t into 1 minus 1 by k. Here d plus x minus t into 1 minus 1 by k. Can I write this total d plus x? So d plus x minus t into 1 minus 1 by k. What is the condition? We increased this separation to bring the capacity back to its original value with A. If C dash is equal to C naught. Whenever we increase this separation, capacity value goes on decreases. Up to what extent? Again it reached to its original value. It reached to its original value, C naught. What is this x? That is the question. Well, C dash is equal to C naught. Make them equal. Epsilon naught A by d plus x minus t into 1 minus 1 by k is equal to C naught. Epsilon naught A by d. Epsilon naught A by d. What are the cancellations on either side? Is 2. Then d plus x minus t into 1 minus 1 by k is equal to d. What you can write from this? Take d on that side, x minus t into 1 minus 1 by k, d minus d, 0. Well, then what is x? Separation, x is equal to, this is minus, you take it on that side, t into 1 minus 1 by k. This is the separation needed to bring the capacity value back to its original or potential value back to its original. Important model. Right. In the same question, they ask, what is the value of k in terms of x and t? Can't we find? See here, x by t is 1 minus 1 by k. 1 by k, 1 minus x by t. 1 minus x by t. Then this is t minus x by t. Right? Then k is equal to t by t minus x. They ask this question. K is equal to t by t minus x. Okay. Come on, note down. Dielectric constant value in terms of thickness of the slag and extra separation made x. Next, Next model. Metal slab or metal plate is introduced between plates. What happens to the capacity? See, this is the capacitor. A between them, separation is D, area of cross section is A, then C naught is equal to epsilon naught A by D capacity. Then what is that? When a metal slab is introduced, same separation D. Now what I am doing, I am introducing a metal slab as direct. This is metal slab or metal plate of thickness T introduced between the plates. Then what happens to the capacity? Whenever they give a word metal slab in the problem, immediately idea should come to your mind that its K value is infinity. Yesterday we discussed. For a metal slab, dielectric constant K is infinity, right? K is equal to infinity. Completed problem. It is just like a dielectric whose dielectric constant is infinity. It partially introduced between the plates, right? Partially introduced between the plates. Then what is the capacity? Formula is known when partially introduced. See here, that new capacity epsilon naught A by D minus T 1 minus 1 by K. Is it not the formula? When a dielectric slab is partially introduced. In this particular case, for metal, K is equal to infinity. In place of K, take infinity. Yes? Then C is equal to A by D minus T 1 minus 1 by infinity. 1 by infinity is 0. Then C is epsilon naught A by D minus T. That's it. On the same, they ask the question like this. This is a dielectric capacitor, please. And the gap is completely filled. Gap is completely filled with a conducting material. Conducting material or metal. Conducting material K is equal to infinity for metal. Then what is capacity here? What is capacity? We know completely filled. K epsilon naught A by D. K is infinity. Infinity epsilon naught A by D. Capacity becomes infinite. Means it no longer acts like a capacitor, it behaves like a conductor. This is metal plate, this is metal plate, this is the metal introduced between. It no longer like a capacitor, it is a conductor. Infinite capacity. In the same, this is one metal plate, this is one metal plate. metal plates. Now these are joined with a metal wire like this or like this, anyway, but in the previous sentence they asked like this. They joined with a metal wire. These two plates are joined with a metal wire. Then what is the capacity? It is just like shorting these two, connecting two metal plates. It's no longer be a capacitor. C is infinity. It's just like a conductor. They short. Two metal plates are shorted. This is metal. This is metal. If I give positive charge, if I give negative charge, simply they flow. Neutralize. It is not at all a capacitor. It is just like a conductor. Just like a conductor. There is no potential difference. Like a metal wire. Infinity. Right? Come on, note down. We continue tomorrow with some more interesting examples. Thank you.